Okay, so we ran into some technical difficulties, so I'm just going to go ahead and run through the lesson real quick on video so you guys can go ahead and get the notes and do the homework. So today is 12.1, and we're looking at angles of polygons. All right, so first it helps to know what a polygon is. Well, a polygon has three characteristics that I like to focus on. A polygon is always a closed figure. A polygon has no curved sides, so no curves. All the sides are flat, straight edges. And it has no overlaps, right? They only touch where edges end, right? So no overlaps. So this I find is more helpful to go through some non-examples. So if we go ahead and take a look at this, is this a polygon? Well, the answer is no. It's not closed, right? Go ahead and take a look at this. Is this a polygon? No. It's a circle. It has curves. Right? Let me go ahead and take a look at this. And this one will have to be more specific. Is this a quadrilateral? No. Well, it does have 1, 2, 3, 4 sides. The sides overlap right here, so you can have no overlaps. Now, if I asked, is it a polygon, you could say, yes, it's two triangles, but it's not a single polygon. All right? Now what we're going to do is we're going to make a quick table of different types of polygons. And this is a lot of your vocabulary. So I expect you to know all of these names. Okay? So here we're going to start our table with number of sides. Right? And then we'll have name. And then we'll have an example. And then here we're going to have a blank. And we're going to come back and talk about that one. And then here we're going to have the sum of the interior angles. Alright, so this symbol right here just means sum. Right, so if we add them all together. Alright, so we'll start with the basics. Our good friend with three sides called the triangle. If we draw a triangle, it looks like that, three sides. And we know the sum of the interior angles of a triangle is 180 degrees. We talked about that already, right? We already learned that. Now we go ahead and we can move on to the next shape, which is actually our main topic this chapter, which is quadrilaterals. Okay. I'm just going to draw a nondescript quadrilateral, right? Because quadrilaterals don't always have to look the same. A lot of people tend to think square or rectangle. I tend to think a symbol from Star Trek. All right? So I got 1, 2, 3, 4 sides. Now here, the sum of the interior angles of a quadrilateral. Well, if we think to a square or rectangle, we know that they always add up to 360 degrees. So maybe you ask yourself, well, where does that come from? Well, I can connect the diagonal here and make it into two triangles. Each one is 180, so 180 plus 180 is 360 degrees. Next up on the list is a five-sided figure called a pentagon. And again, I need you to know the names of these shapes. There's a pentagon, 5 sides, right? And here, I can do the same thing. I can start to cut it into triangles. Now, to do this, you want to make as few triangles as possible, and you always want to start at the same vertex. So if I start here, right, I can kind of chop off this first triangle here. Then starting at the same vertex, I chop off a second triangle here. And then you'll see I have a third triangle left. So that's 3 triangles. So I go ahead and do 3 times 180, and I find that the sum of the interior angles is going to be 540 degrees. So that's kind of the key here, is you think to yourself, all right, how many triangles would I be able to cut that shape into? So we take a look here at our next shape, the hexagon. Right. There's a hexagon, no matter how bad I draw it. I know that bottom side is curved, don't judge me. All right. I'm going to start lopping off triangles. There's 1. There's 2. There's 3. And there's 4. So we start to see a pattern emerge, right? By the way, 4 times 180 is, of course, 720 degrees. right? We start to see this pattern here, right? So here, a triangle has 3 sides, right? So if this is the number of sides, we call this n, right? We can talk about the number of triangles. So here, if n is 3, there's 1 triangle. If n is 4, there are 2 triangles. If n is 5, there's 3 triangles. If n is 6, there are 4 triangles. So hopefully what you start to notice is if I go all the way down to the bottom of my list, I can talk about a general shape with n sides. And if a shape has n sides, we would call that an anagon. And we can see here, 6 minus 2 is 4. 5 minus 2 is 3. 4 minus 2 is 2. So n minus 2 is n minus 2 triangles. And then if each triangle is 180 degrees, this will be n minus 2 times 180 degrees. So that's our formula for the sum of the interior angles of a triangle. Okay. Real quick, I'm going to run through some additional vocabulary here that I expect you to know. A 7-sided figure is called a septagon. An 8-sided figure is an octagon. 9-sided figure is a nonagon. And a 10-sided figure is a decagon. I need you to know these shapes by name, okay? But after that, you can get creative, right? Let's say a figure has 27 sides. You're just going to call that a 27-agon. And that way I know n is 27, all right? So that's our first realization here, and we can now fill in the rest of this if we want. But the big takeaway is the sum of the interior angles will always equal n minus 2 times 180, where n is the number of sides the shape has. Okay? So that's our first big takeaway. We can do an example, right? If we have to go ahead and figure out, well, what is it for a 17-agon? Well, I'll just go ahead and do 17 minus 2 times 180, which is 15 times 180, which is 2,700 degrees. Okay? So again, very easy formula to follow. All right. Let's go ahead and extend and talk about more vocabulary. Now, when we talk about shapes, we can classify them as one of 2 ways, right? One of the ways we do that is we talk about shapes that are convex versus shapes that are concave. And this is a really, you look at it and you know type thing. So here is a convex hexagon. And here is a concave hexagon. Right? So this one's convex, this one's concave. Well, what's the difference? Here, if you look at the one on the left, all of the angles are less than 180 degrees, right? If I were to draw an arrow where this angle was, boom. Arrow where the angle is, boom. Angle, boom. Angle, boom. Boom. All the angles point out, right? So that's one way to say it is convex, right? All the angles are less than 180 degrees. Okay? Concave, it's different, right? This one here points out, this one here points out, but this one here points in. Once one of the angles points in, right, that means you have any angle that is greater than 180 degrees. Then it's concave, right? So if the angle's pointing in, it's concave, which kind of makes sense, right? Going into the cave, all right? The next way we talk about polygons is we can break them into either regular or irregular. So what makes a polygon regular? Well, regular polygons, all the sides are congruent, and all the angles are congruent. Since all the sides and all the angles are congruent, as a matter of kind of fact, right, all angles congruent means that it will always be a convex shape, right? Because all the angles will have to be congruent. They'll all have to be less than 180, all right? Any questions there? Good. I can't hear you anyway. All right. So here, now we can go ahead and extend this even further. So now we talk about regular polygons. I can ask you to find the measure of one, right? Just one interior angle. An interior angle of a regular polygon. Right? We'll say regular anagon. Well, let's do this first by example, right? If we think about a pentagon, right? Pentagon. For a pentagon, n equals 5. So I go ahead and I figure out what all the angles inside, right? So all the angles, the sum of the interior is equal to n minus 2, 5 minus 2 times 180. So I find that this is 540 degrees. So I know all the angles inside the pentagon have to add up to 540. Now here, because it's regular, extremely important word, I know that all the angles are congruent. And how many angles does a pentagon have? Well, it has 5. So if I do 540 divided by n, so just one angle, equal 540 divided by 5, I find that they're each 108 degrees. So now we can kind of generalize that, right? If I just want one interior angle, it's going to equal the n minus 2 times 180, right? I'm going to figure out how much degrees there are inside total, and I'm going to divide that by the number of sides, or the number of angles, right? So the formula we get here is n minus 2 times 180 divided by n. So that'll give me the measure of just one angle. If I want to go ahead and do this for my 17agon, right, from the last page, all right, 17agon, it's going to equal 17 minus 2 times 180 divided by 17. So you know 17 minus 2 is 15. 15 times 180 is 2,700. Divide that by 17. We get a number that's about 158.8 degrees. Okay, so again, that's how that formula works. Fairly straightforward. All right. So those are the interior angles. Some of the interior angles and one interior angle. Now we're going to talk about exterior angles, right? So let's talk about exterior angles. I'm going to go ahead and draw a triangle. And it's not just any triangle. This is going to be a regular triangle. So all three sides are congruent. It's equilateral. It's also equiangular. So we already know equilateral triangle, boom, every angle here is 60 degrees. Now if I take a look, I should be able to figure out what the angle is right next to it, the exterior angle, right? Because the interior and the exterior angle will always make a linear pair. So if this is 60, the angle right next to it has to be 120 degrees. So all of these angles are 120 degrees. So what do the three exterior angles add up to? Well, 120 plus 120 plus 120 is 360 degrees. Let's see if we can spot a pattern. All right, if I go ahead and take a look at a quadrilateral, a regular quadrilateral, also known as a square. All right, 1, 2, 3, 4. I know all these angles are 90 degrees. So what are the angles next to them going to be? Well, 90 degrees. 4 90-degree angles is, you guessed it, 360 degrees. Probably a coincidence, but let's go ahead and try with one more shape. The pentagon. This is a regular pentagon. All 5 sides are congruent. Right, I want to get my exterior angles. Now we already did this, right? We found that if it's a regular pentagon, all of the interior angles are going to be 72 degrees, right? We did that. Oh, I'm sorry, 108 degrees. We did that right here. So these are all 108 degrees. So what's the angle next to it going to be? 72 degrees. There's 5 of them. 5 times 72 is, you guessed it, 360 degrees. So this is our next fact, right? Which says that the sum of the exterior angles is always 360 degrees. Do not put anything else, right? In the words of the police officer at the end of National Lampoon's Christmas Vacation, if I had a rubber hose, I would beat you, right? If you put anything besides 360, please know that if I had a rubber hose, I would beat you, all right? So then here, how would I get one exterior angle? This is our third formula here. One exterior angle. Well, I'm just going to take that 360 and divide it by n. Okay, so that's how I get one. All right. So here, what is this going to look like on a test? On a test, I'm going to ask you, hey, all right, given a shape, I want to know, A, the sum of the interior angles. I want to know the measure of one interior angle. I want to know the sum of the exterior angles. And I want to know the measure of one exterior angle, right? And then I'll give you a shape, right? And maybe I'll put something like, I don't know, let's do something easy. We'll do a septagon, okay? So if I tell you it's a septagon, well, what do we know? By the way, you can pause and do this problem now, and then come back and check your answer. So a septagon, we know here that n is equal to 7, right? It has 7 sides. So if I want to find the sum of the interior, I'm going to do 7 minus 2 times 180. If it has 7 sides, it has 5 triangles. 5 times 180 is 900 degrees. So there's my answer to part A. One interior angle. Well, if I know all the angles inside add up to 900, to get one, I'm just going to do 900 divided by 7. 7 goes into 9 one time with a remainder of 2. 7 goes into 22 times with a remainder of 6. 7 goes into 68 times with a remainder of 4. So we'll call that 128.571428. 14285. Yeah, repeating, all right? And again, you could just round that and call it 128.6 degrees. That's fine, right? So there's my answer to part B. Part C, the sum of the exterior angles. I'm telling you, if you get this wrong, I will find a rubber hose and I will beat you with it. 360 degrees. It's got to be automatic, all right? Now, one exterior angle, I'll go ahead and do 360 divided by 7. 7 goes into 35. 5 times with a remainder of 1. So we get 10. 7 goes into 10 one time with a remainder of 3. 3/7 is equal to 0.428571. Repeating. So I get this. You could probably just round that to 51.4 degrees. All right. Now check this out. How do I check to see if this is right? What do these two angles add up to? Boom, 180 degrees. So that's how I know I did it correctly. All right. Please take your time with your homework. Email me early and often if you have questions. You got this. Read the directions carefully.